As for the bell ringer, what should we do first on number 1? I did the same thing first period, and that's not the right thing. I should combine like terms first. So, we keep talking about I'm changing up the bell ringer test, and it is happening on Friday. What will probably happen is instead of saying, Grant, pick the right answer to May 9th's first bell ringer, I'll say, Grant, here's May 9th's first bell ringer. Show me how we worked it. That seems a little easier for me. Should be a better grade for Grant, one would assume, if he's been taking notes. He's got enough advance notice where he surely can get it together. Negative 1.7 times negative 6. Tilly, I'm hot. You're going to have to turn on low cool. 11 point what?
It's not 11.8. It is.
Okay, this is what happens first period too, and this is why they got in trouble. The same 3 people help me all day, every day. The same 3 people also have like the highest grades in the class. There's a correlation. So what else? Pull out your phone, pull out your calculator. Somebody multiply those 2 numbers together. You made it to me. That means you can multiply. I got 10.2. 1.7 times 6.
But it's 0.6.
It's the negative 6. I did negative 2 plus a negative 4. I got negative 6. I need to know negative 1.7, negative 6. You did this and you got what?
11.32.
2.2?
Yeah.
Okay.
That's what I thought you were
Okay.
asking.
Okay. I understand.
Shouldn't it be negative?
It should. Thank you. Okay, so we need to solve for R. So I add 11.22 to both sides. I got 10.2R equals something.
26.52.
50 what?
3.
There's a 2 there. It should be 52. 3 plus 2 plus 0 is 2. 3 plus 2 is 5. 5 plus 1 is 6. 2 plus 2 is 2. That's right. Okay, so 10.2R equals this, so I need to divide both sides by 10.2. And I get R equals some number. Okay. Again, I'm not trying to be ugly, but these are algebra bell ringers. You've already passed this. You're already beyond this.
This one that almost said was that's not what I got.
I didn't say anything. I just looked at Katie's head, as usual. You said something about PEMDAS. Yeah, you could distribute first, but it's going to take longer.
If I did that and still got the numbers, does that mean I'm done?
No, it means you probably didn't. It would have been easier if you'd done this. You made it too complicated. Then move. Pick a different spot. Okay, on the next bell ringer, I need to distribute that 5/3. So I would have 10 over 3 plus 5/3 x. My God, we did fractions in like elementary school. Either at the end of elementary or early middle. One of these fractions can reduce. Which fraction can reduce? What can it reduce to? So I have 4 fractions. 2 of them have 3 as a denominator. 2 of them has 5 as a denominator. I need them all to have the same denominator so I can combine some things. So it has to be 15. I'm just going to go ahead and tell you that because last period I had to tell them too. Why? I don't know. It's just annoying. Okay, so times 5 times 5. I got 50. They're just quiet. They're quieter than you. No. Okay, so I got 50 over 15, 25 over 15, 12 over 15, and 6 over 15. Those all have 15s in the denominator. That was the plan. That was the plan. Could you have changed it all to decimals to begin with? Yes. Would that be wise? No. As
Like I got the right.
you would for this one, because 0.8, 1.2. Yeah, you would for this one. Is that what you were supposed to do? Okay, so if I solve for x, I subtract 12 over 15x. minus 12 over 15x. I'm running out of room, and I'm writing on tomorrow's bone ringer now. I get 50 over 15. It's okay if you write on tomorrow's bone ringer as well. 13 over 15x equals 6 over 15. I subtract 50 over 15 from both sides, but I'm out of room, so I can't show it. 6 minus 50 is negative 44. And then I get to the end, and I'm supposed to solve. What do I multiply by to get x by itself? Bless you. I end up getting x equals negative 44 over 13. It was long, yes. It took a few minutes, yes. That's all that can be said, though. Okay, yesterday we discussed the equation of a circle. Today we're discussing circles and circumferences. I have hole punched the wrong side. You need to flip to the back first where it says example 1. A lot of these vocab terms are repeaters that you've already heard or used. For instance, you already know diameter, radius, circumference, center, sector. There are lots of vocab words with circles that you've already learned, even in here. Okay, but of course the first blank is something you know the word, but you've never heard it with a circle. Well, maybe yesterday. I don't think I threw out the term, though. Equidistant. A circle is a figure in which all points are equidistant. Just like yesterday, when we knew that radius, we could count up 3, down 3, right 3, left 3. All points were 3 units away from the center. Literally, all points would be 3 units away from the center. Then it says a blank is a segment whose endpoints are the center and a point on the circle. What should I put in that blank? A radius. Clearly, I've already highlighted CE. Can you give me a different example? CD would work, or CF would also work. Then it says a blank is a segment with endpoints on the circle. Endpoints on the circle. So my example is AB. It's called a chord. So the weirdo looking line that's not cutting through the middle is called a chord. If it touches both ends and doesn't have to touch the middle, it's called a chord. So my example is clearly going to be AB. What is another example of a chord? Why is CF not an example? It says endpoints on the circle, right? And it didn't go all the way is what Nick said. So it has to have endpoints on the circle. CF, C is not an endpoint on the circle. DE would work. And then it says a blank is a chord passing through the center. You're not going to be surprised with this. A diameter. If it's a chord, meaning both endpoints are on the circle, and it passes through the center, it is a diameter. There is only one available for this. What letter should I put? DE. It has to be DE. I know on the semester exam, at least, because I was working on that last night, there is at least one like this, where you have to identify, is this a chord, a radius, a diameter? Like, what is this? Okay, you don't need the formulas in the box. You don't. You already know how to go from a radius to a diameter. But we'll humor the notes and go ahead and work example 1 quickly. What is QV?
Radius.
I'm sorry. Say what's QB.
Okay. So if QB is a radius and they want to know the diameter, what number should I put? Yes, because it's double. Then they tell me TU is 14 feet. What is TU? And then they say, what is the radius? So what's the radius? 7, because you divide it in half. Okay, and then they tell me QT is 11. What is QT? And then what is QU? Look at your picture. Is QU a diameter? It's another radius. So what number should I put? 11 again, because they're both radiuses, so they're both the same length. So our first example is as easy as it gets. Our second example, we're finally going to complicate things a bit in that we have 2 circles. So we have circle S. You name a circle by its center. That's why it's called S, because S is in the center. Circle S has a diameter of 30 units. So from C all the way to the end is 30. Circle R has a diameter of 20 units.
Keep blinking. Whatever how it's there comes.
And DS is 9. So from here to here is 9. They want us to find CD. What's the answer? Why?
Because it's the radius is 50.
Sure. Thank you. So we know that that diameter was 30. Half that would be a radius. So CS is a radius. We know 6 plus 9 is 15. If you were wanting me to pull out that magic bag of candy that I've hidden from you for some time now, what are we technically using to know to do this? We had a postulate that let us know the 6 plus the 9 is the 15 when it came to this kind of thing. Yes, that's it, Trey. When we get done with notes, I'm going to pull out my magic bag and you can have some gum. It's called the segment addition postulate. That was good. Okay, so do you have to know that? No, you know 9 plus 6 is 15. It was common sense then. It's still common sense now. Okay, they asked for RC. We found CD is 6. How long is RC? Why is it? Which one is it? 3 or 4?
4.
Why is it 4?
Because 10 plus 10 is 12.
Okay, so a radius like RD would be 10 because the diameter is 20. So the radius is half, so it'd be 10. We know that 10 minus 6 is 4. So we know that RC has to be 4. But really, this is about a medium. We're still not too hard. Are there any questions about example 2? Then flip to the back. We're going to go back to another easy. I say it's an easy, and if you don't already know this formula, then it's not an easy, because it's one I expect you to know. Circumference is pi times diameter. If you want to use circumference is 2 pi radius, then you can, but I always did pi times diameter, so I just whew. Okay, so the circumference is the distance around it. So, like, when I think of circumference, you know how I am. We talked about with sectors, I think of, like, a piece of the pie, a slice. With circumference, because I'm always thinking pie when I think circle, I think crust. We want to find the crust. And then they go on to say that you can find it and with using pi, and they tell you pi is 22 over 7 or 3.14, but this is geometry, and you've been pressing that pi button in your calculator for some time now, so keep on pressing it. Okay, so we're not going to do the third one. We'll just do the first two. It tells me a circumference is pi times diameter. What number should I plug in for that diameter? So I need someone to type in their calculator 79 pi. I heard 0.9 and 0.3.
I got it.
0.1.
Yeah, I got it. 1.8.
So 1.9 would be 2.
No.
Yes. 9 would be 2.
It was 248.19. I don't know where my notes are from last period. I didn't think I would need to reference.
Yeah, that's what it is. So if it's 1.8, then it's going to be 2.
I just did 2.8 for 1.9 feet. That's what I did last period. It's what I'll do this period. Creature of habit. Okay, and then circumference equals, well, it should have specified in the directions if they wanted tenth or hundredth. That's my bad, really. Pi times diameter. So circumference is pi times what? What do I plug in? Why? So the diameter is 2 times that radius. So you did 2.5 times 2. That's how you got the 5. Because they gave you the radius in that one, trying to complicate your life. You type 5 pi in your calculator, I'm sure you get 15 point something. Give me 2 decimals, because I did 2 decimals in the last one. Thank you. We will skip the example with the round table. We will go on to, are there any questions about example 3? If you don't know that formula already, it's one you've already done before, but it's been a while. If you don't know that formula already, you've got to learn that one by Thursday. You've got to learn it by Thursday. Okay, example 4. Find the diameter and the radius, thank you for specific directions, nearest hundredth, of a circle whose circumference is 106.4. So again, I write my formula. I plug in 106.4 for the circumference. I need to solve for that diameter. What do I do?
106.4 divided by 5.
Great idea. And you get
33.9.
you didn't follow directions then.
33.87.
Okay. And then so the radius would be Eric, redeem yourself.
16.94.
Is it 9.4? I wrote 9.3 last period. Is it 9.4?
No. It's not that you don't.
Okay. Let's face it, Eric and Nene would get all their points. What I counted off on was if it said 100, and Katie only gave me 1 decimal. That's what I've been counting off on. Not Katie can't round, unless it's a really bad rounding, like super bad. Okay, we will skip example 5 because it's just like example 4. I mean, just like. And we will go straight to the hard example of the day. And it also is the one more than likely. So if you're wondering what's going to be on a standardized test in involves circles, this would be it. This would be something I would expect to see on the ACT. They love them some inscribed and circumscribed polygons. Okay, if it's inscribed, that means it's inside. Inscribed means it's in, if you read the sentence, quadrilateral is inscribed in circle K, so it's inside of circle K. Circumscribed is obviously on the outside, so inside shape, outside shape. Circle K is circumscribed about quadrilateral element P. So circumscribed K is, I want to say circling about, or is just on the outside of quadrilateral P. Okay, so you need to know the two words inscribed and circumscribed. You do need to know those. And then, of course, we're going to complicate our lives and go to the next example that's not drawn for us. I'm going to draw me a big circle. I know it's got a center at J. It says there's a square. I'm going to try to draw a square, but since my circle's not perfect, my square is going to be more of a rectangle. So they tell me that the square has side lengths of 9, and it's inscribed in circle J, and they want me to find the diameter of circle J. And you're going to think I've lost it, but we know the diameter is just 2 endpoints going through that center, so I'm going to draw my diameter like this. Any ideas as to why I drew my diameter diagonally rather than straight across? But why? What shapes do you see now? Are you surprised? Don't we always turn things into a triangle problem? So I'm going to color my triangle, one of them. I have a right triangle. Part of the triangle is missing. What part of the triangle is missing? Okay, I need to solve for that hypotenuse. How can I solve for that third side? So set it up for me. Or I could do C, it doesn't matter, it's a variable. Am I done? There was someone on the last test. They had almost all the right math. They would solve for like the missing piece, and then they would say that was the surface area of the lateral area. They would forget to plug it back into the formula. I have to plug this back into the formula. What I solved for was the diameter. I have to plug that into that circumference formula in order to reach the correct answer. What number did you get? I got 39.99 as well, so I went ahead and rounded to 40. And then if we were being honest, I would say I'm impressed that you recognize the triangle. I'm impressed you knew how to solve it. But I could be more impressed. What could we have done differently? It is a 45-45-90 triangle. It is an isosceles right triangle because the 9 and the 9. So we know it's a 45-45-90, and we're given a leg. How do you go from a leg to a hypotenuse? So I bet if you type in your calculator 9 square roots of 2, you get that exact same decimal. And that would have been so much faster. In fact, I would have done circumference equals pi times 9 square roots of 2 and let my calculator do it all in one step. At least you caught it. Okay. So you've been given your worksheet. Again, I'm going to post the key, so I expect to see some sort of work on it.